Hi, my name is Rishabh Bhargav, and I'm excited to talk about how at Datacoral, we have leveraged AWS services to automate data pipelines for mutual customers, so they are able to understand their data and solve critical business problems. Organizations today want to use data to make better decisions for their businesses. However, their data lives in many different places, such as databases, SaaS applications, file systems, etc. And this data is changing rapidly. Datacoral is the data engineering platform that allows users to easily and reliably extract data from many different sources into their data warehouse of choice. Let's look at an example use case. One of our customers is a healthcare technology company who wanted to understand the impact of COVID-19 on their churn rate. To be able to do this, they needed to combine data from multiple sources: product usage data from their production MySQL database, sales data from Salesforce, and customer support data from Zendesk. They use Datacoral's MySQL change data capture connector and Salesforce and Zendesk API-based connectors to replicate data in near real time into Redshift. With high quality data from all these sources available for analysis, their data science teams were able to use SQL to test multiple hypotheses about their churn rates. And these insights have allowed them to have a much better understanding for their sales and marketing projections for 2021. Similar to the connectors just mentioned, Datacoral supports 80 plus connectors of different types. And our customers are using our connectors to replicate over 400 billion records per month, from extracting data from tens of sources to providing sub 15-minute latencies. Our customers rely on us for robust data integrations. Building data pipelines and building automated data pipelines is complicated. Let's look at some of the challenges involved. First, when dealing with any organization's sensitive data, we need to ensure that no data leaves their environment to maintain data security. Data pipelines must scale up and down as data volumes change. There should be guarantees on data quality and freshness so data scientists can actually rely on their data. The architecture should integrate well with other services, recover from errors automatically. The system should be observable with easy to monitor metrics and automated alerts. And finally, the architecture should offer pay-as-you-go pricing to minimize costs. Now let's take a look at the Datacoral architecture. We follow principles of infrastructure as code, so all AWS resources are spun up using CloudFormation templates. For data security purposes, this architecture is actually deployed inside our customer's VPC. This ensures that no data leaves our customer environment. IAM roles and policies are used throughout, and our software is provided as a fully managed service. A customer-owned cross-account role is used by us to monitor and update a customer's installation. Next, let's take a look at Datacoral's data connectors. Each connector is deployed as its own serverless microservice. This includes a Lambda for processing data, a Kinesis stream for queuing, and we use DynamoDB as a state and configuration store. Each connector being its own microservice ensures that they're isolated from one another and can scale up and down separately as needed. We absolutely love serverless services from AWS. Each connector is triggered by events from Amazon EventBridge, depending on its schedule. Now, data fetches for each table are run in parallel, and they're further divided into smaller chunks. This micro-batching is what allows gigabytes of data to be processed while adhering to Lambda's memory and time constraints. The state of each sync is saved in DynamoDB, so in case of an error, automatic retries can pick up from where we left off. Data is written into S3, is partitioned by time, and is queryable in Athena. And data is also encrypted using a customer-owned KMS key. As data gets written into S3, another Lambda gets notified, and it triggers the load of this data into Redshift. Additional data quality queries are run before the tables are made available to users. And concurrency of all Lambdas is managed via configuration, so we don't send too many requests too quickly to other services such as Redshift. Finally, logs and metrics are written to CloudWatch, and events about each data sync are written into an SQS queue that can be consumed by external systems for reporting. We are able to offer pay-as-you-go pricing for a fully managed serverless architecture deployed in our customer's VPC. This ensures complete security and scalability. And this is done while solving the hard problem of replicating terabytes of data and providing observability throughout the system. That's it from me. Hope you enjoyed the presentation.